Hi, I'm Royce, and welcome to the first video on algorithmic thinking. In this video, we're going to go over the basic overview of this event. First, we're going to start with the event overview, which is going to be the overview of the event and the event guides. And then we're going to move on to the content, which is going to be all the topics that are going to be in this event. And lastly, we're going to go over some resources, which is for beginners, intermediates, and advanced competitors. So starting with the event overview. So competitors are going to be tested on their general knowledge of algorithms and their ability to develop and write algorithms in pseudocode that solves tasks efficiently. Coding languages can be used, but will not result in the addition of extra points. Pseudocodes can also be written in plain English as long as the graders understand the gist of what you're trying to say. And just note that the competitors will have to compete individually in this event. You can't work as a team. Competitors will take this test with multiple choice and long response questions. In this scenario, long response questions are going to involve writing algorithms to solve tasks. Next, competitors are allowed to prepare a binder, either online or physical, to assist them in this event. Competitors are graded based on their accuracy on the test. If a tie occurs, for instance, the following tiebreakers are used in the order listed. Firstly, predetermined tiebreaker questions. Secondly, fastest time complexity for solving the algorithms. And lastly, the time you take to complete the actual test. Moving on, the test is broken up into two parts, multiple choice and long response, both of which are 50% of the test respectively. The multiple choice section is going to consist of questions on algorithms, time complexities, and etc. And then on the other hand, the long response questions are going to cover solving specific tasks using algorithms. Next up, we have the content for this event. So we're starting with time and space complexity notations. So we're going to have general questions on this topic where we ask you for what the time complexity of the algorithms are. And this is also really helpful when you're trying to solve a task in the quickest way possible. So as you can see over here, there are a couple of algorithms and their time and space complexities. And the time complexity is generally how fast your algorithm can solve it. And this is generally in big O notation or theta notation. For example, the algorithms are quicksort, merge sort, time sort, heap sort, and you can view their best, average, and worst time complexities and their space complexities respectively. Next up, we have complexity classes. So complexity classes help us group problems based on how much time and space is required to solve the problems and verify their solutions. It is really important that you have a solid grasp on the big O notation from the previous slide, of course, and that's going to help you in this. And what might show up on the test? We might have APX, X space and XP time, PS space, NP, or RP. Any of these might show up on the test. So make sure you know how to implement these algorithms and how they work. It might also be tested on the concepts behind these algorithms. Next up, we have algorithmic reductions. So what is a reduction? Let's say problem A is reducible, or more technically, Turing reducible, to problem B. And it is denoted by A is less than or equal to B if there's a main program M that is able to solve problem BA, but it lacks procedure to solve problem B. So you're going to have to assume that A is some new problem that you would like to develop an algorithm for, and then B is some problem that you already know an algorithm for. Then showing that A is less than or equal to B will give you an algorithm for problem A. And this is going to be really helpful when you're going to have a two-set type of question on the test. Next up, we have our general long response questions, which are going to cover search algorithms and sorting algorithms. So for search algorithms, you're going to have a list that you have to know, and that's going to include linear search, binary search, jump search, interpolation search, exponential search, sublist search, Fibonacci search, Ubicious binary search. And these are a bunch of search algorithms that you're going to have to know and use accordingly. Like I said before, you don't actually need to code this using programming languages. As long as you write them in pseudocode or plain English, you'll be just fine. It's just to know that you understand the logic when you're solving these algorithms. And then next we have our sorting algorithms, and these are going to show up on the test, and they include selection sort, bubble sort, insertion sort, merge sort, radix sort, tim sort, cycle sort, and gnome sort. If you don't know any of these algorithms so far, it's fine. We'll be going over them in the resources section where you can learn more about them and conceptualize them to the best of your understanding. Next, we're going to have our pathfinding algorithms, and these are really important since it's going to cover mostly trees. So we're going to have depth first search, breadth first search, flat fill, A sharp, D sharp, Yen's algorithm, Dijkstra, and the minimum spanning tree. And these algorithms are pathfinding algorithms that you can use when you're trying to find a path from one node to the other, and are really helpful. And now for the final section, which is going to be the resources for this event. So one of the first resources, especially for beginners, is USACO Guide. And USACO is basically the United States Computing Olympiad, and you can go join that as well if you want. But this guide includes algorithms and exercises for specific algorithms, and it's divided into multiple levels, specifically bronze, silver, gold, and platinum. And platinum is going to be the highest level of difficulty on this site. And you can use this site to practice your problems, learn algorithms, and especially the algorithms that are going to be covered on this test. And note that the algorithms, and when you're solving these tasks, you're going to be actually writing your pseudocode or writing them in plain English in your long response questions. And next, we have a book called Algorithms by Jeff E. And this textbook is best because it covers the logic behind solving these algorithms. So this event is more logic than actually coding. So it's important that you understand the logic on how you have to solve the algorithm as fast as possible. And this textbook actually also includes many of the search and sorting algorithms that are covered in the test. And next, if you're having trouble with any of the sorting algorithms, I would suggest you go to Geeks for Geeks, and this contains hyperlinks to explanations and code for all of the sorting algorithms that are going to be covered in the test. And next up, we're going to have the search algorithms. Same thing on Geeks for Geeks. They have a really good code explanation for all of these algorithms. Good luck.